Right, so we're going to talk about calculus motion. Now, this part of calculus is mainly physics. Okay, it's mainly physics, that is equation of motion. But it can also be tested in maths. So we need to be aware of it because in recent years they have not brought it in trial papers and so on, even the final examination. You never know, maybe you might see it in a trial or final examination, so you need to be there. So first thing, you need to know some very important physics terms, starting with velocity. Okay? Velocity is just the rate of change of position of an object. Okay? And it has got both a magnitude and a direction. So velocity is also related to speed, but speed has no direction, but velocity has got direction. So if you want to simplify it, you can just say velocity is speed with a direction. So velocity is actually denoted by a small letter v, and it is measured in meters per second. The units of velocity are meters per second. Okay? Now, the word velocity, we don't normally use it in everyday life because we are mainly used to using speed. But speed and velocity are related. The only difference is that velocity has got direction, whilst speed doesn't have direction. Then we have got a second term or word which is also related to velocity, that's acceleration. Acceleration is the rate of change of velocity. So the rate at which velocity changes is what's called acceleration. Now, it's important for you to know that velocity itself is also a rate. It's a rate of change of position or displacement. Now, in physics, position is also called displacement. Okay? And the two are denoted by a small letter s. So position is denoted by s, and displacement is also denoted by s. Now, position and displacement are related to distance. Okay? They are related to distance. But position or displacement has got direction, while distance doesn't have direction. And they are measured in meters. Okay? That's the standard unit, meters. That's the standard unit for position or displacement, or you can say distance. Right? So acceleration is the rate of change of velocity. And the unit for acceleration is the meters per second squared. Meters per second squared. Alright? Now, generally, you'll be given what's called a displacement function, ST. Okay, remember I said position refers to displacement, distance. You can also represent height of an object. It's the same. So position, displacement, distance, height, they are the same. Okay? So the velocity of an object at any time t is given by s prime of t. S prime of t is the derivative of the displacement function. And it can also be written as ds over dt. St is the displacement function. Its gradient is velocity. Okay? St is the displacement function. Its derivative is velocity. So Vt is the same as s prime of t, also equal to ds over dt. Then acceleration now, okay? Acceleration is the same as the gradient of a velocity function. So if you're given a velocity function, you find its derivative, that would be acceleration. Then if you are given a displacement function, if you find the second derivative, you end up getting acceleration. So you can either start with st, then you find s prime of t, that's velocity. Then s double prime of t, that's acceleration. Now, just to simplify, acceleration is the rate of change of velocity. So this is also equal to dv over dt. That's acceleration. Are you following that? So we have at, that's acceleration. It's also equal to the first derivative of velocity function. It's also equal to the second derivative of a displacement function or a displacement function. It's also the same as dv over dt. Okay, so at the time when the object reaches its maximum or minimum displacement from its initial position, then it changes its direction, then the velocity will be zero, which means we just equate that displacement function to zero. Okay, we are talking about at the maximum turning point, like this, or at the minimum turning point here. Velocity will be zero. Okay. Then you also need to know that you can read this further on yourself, on your own, that speed and velocity, they are more or less the same. They are the same unit, but they have got different signs. Velocity can be negative, but speed can never be negative. Right? Acceleration as well can be positive, it can be negative. When it's negative, we say that's a deceleration. So acceleration can increase or it can decrease. If acceleration is increasing, it means velocity is also increasing. So if velocity and acceleration have got the same sign, it means the object is speeding up. If their signs are different, it means the object will be slowing down. So these are some of the concepts that you are expected to know when it comes to calculus of motion. It's still part of calculus. Are you following that? So your knowledge of the quadratic function is also a part. Okay, let's talk about an example now. So the height in meters now, height is the same as position, the same as displacement, also distance. Okay? So the height in meters of a stone thrown upwards from the top of a building is given by this function. That's a quadratic function. Okay? The coefficient of t squared is negative, so it looks like this. The very maximum turning point, where t is the time in seconds from the moment that stone was thrown. So if a stone was thrown upwards, like that, goes up. So the first question says, from what height is the stone initially thrown? The moment you're talking about initial, it means t is 0. You're talking about at the beginning. The time is 0. So all you have to do is substitute t equal to 0 into the function that you have, that is in this case h. So you get h equal to 35 meters. This on the graph is more like your y-intercept. Okay, remember we did a question on rates where we also had a function which looked like that. That's the same concept. There's a relationship. Questions on rates of change and also calculus of motion, there are some similarities. So initially, when the throne is thrown up, we need to know at what height was it thrown from. So that height is 35 meters. You just substitute t equal to 0 into the function. Then number 2 says, at what velocity is the stone initially thrown? Once you have got initially, it means t is 0. But since we want to calculate velocity, we have to find the derivative of this function. The derivative of that height function is velocity. Okay? So h prime of t is going to be 30 minus 10t. So if we find the derivative of that, it's going to be 30 minus 10t. Then you substitute t equal to 0 to determine the velocity when the when the stone is first thrown up. So it will be 30 meters per second. Please remember, velocity is the gradient of the height function, of the displacement function, or of the distance function. Velocity is the gradient of the height function, displacement function, or distance function. So here we are given our function in terms of height. So the gradient of that height is the velocity. But since we want to know the initial velocity, we substitute t equal to 0 into the derivative of the height function, which is the velocity. Okay? Then the next question now says, what is the velocity of the stone after exactly 2 seconds? Now this is also easy, because we are trying to calculate velocity, but in this case now it's after 2 seconds. So we find the derivative, which is this, then we substitute t equal to 2 seconds. Okay? So it's very straightforward. So find the derivative, then substitute t equal to 2. You get 10 meters per second. Alright? Velocity is the gradient of the given function, which in this case it's height. Right? Then the next question says, what is the acceleration of the stone? Now, acceleration is the second derivative of this height function, or you can say it's the gradient of the velocity function. Okay? So, there are two ways. We can just find the derivative of our first derivative. Remember, our first derivative velocity, the rate of change of velocity is acceleration. So the derivative of the first derivative is going to give you 10 minus 10. So what this means is that our acceleration is going to be negative 10 meters per second squared. And this, we call it a deceleration in physics. So the object is going up because of the force of gravity, it's being pulled down. So it will be decelerating, means it's becoming slower and slower until it gets to a maximum where the velocity becomes 0 and then it starts falling down. So this minus 10 here indicates that there is an opposing force from a physics perspective, and that force is the force of gravity. So when it's coming down now, it is now accelerating. But when it's going up, it will be decelerating. Okay. Then, number 5, after how many seconds does the stone reach its maximum height? Right. Now we need to know how long is it going to take for the stone to reach the maximum height. To do that, we just find the derivative. We know that at the maximum height, the derivative is 0. So find the derivative. Then equate the derivative to 0. Then solve for t. You get 3 seconds. So h prime of t is 30 minus 10t. Then you take the derivative to 0. Then you solve for t. Remember, this is maximum here. From what I told you last step, or rather before we close school, once you see the word maximum when you are dealing with a question on calculus, it means you have to find the first derivative. Then equate that derivative to 0. So maximum height, you can get it when the gradient is 0. And the gradient of the height function is velocity. So you equate that to 0 and you solve. Then the next question says, what is the maximum height? Now, to get the maximum height, obviously, we have to use the time it takes to get to that maximum height. We found the time it takes to get the maximum height. Now we need to determine the value of that maximum height. So we write our function, original function, then we substitute the time it takes to get to the maximum height. And the answer will be 80 meters. Our height is in meters here. It's bigger. Sometimes it can be in kilometers, but for this question, it's in meters. You following that? Okay, then number 7. Do you have any question? Then number 7, that one there. At what speed does the stone hit the ground? Okay, so when the stone is thrown up, obviously it will come down. We might need to know how long is it going to take for it to get, or rather, at what speed is it going to hit the ground. Now, to do that, we know that at ground level, the height is what? 0. So all we have to do is substitute that h by 0. Then we solve the quadratic equation. Okay, remember you are in metric, so you expect to know how to solve quadratic equation. So you can solve, this can be solved by factorization. So you take out the common factor, which is 5, right? And then you get t squared minus 6t minus 7, which can be factorized to t minus 7 times t plus 1. But time is never negative, it's always positive. So we take t equal to 7 and reject t equal to minus 1. So what this means is it will take 7 seconds to hit the ground. But those 7 seconds now, we need to substitute them into the velocity function, because the question is asking for speed. Speed and velocity have a relationship. Okay? So when you substitute the t equal to 7 into the velocity function, remember we got our velocity function before. It's our first derivative. So we substitute, you get minus 40 meters per second. But because this is speed, okay, speed does not have, it doesn't have direction. Therefore, our answer for speed, it will be 40 meters per second. The minus 40 meters per second, that's the velocity. But we are dealing with speed, which doesn't have direction. So the answer will be 40 meters per second. If the question was saying velocity, it would be 40 meters per second as well, but it would be 40 meters per second downwards. Velocity has got direction, but here it's speed, so the answer will be 40 meters per second. Now I want you to be aware that this question here, it has got 2 parts. First, you need to find the time it will take to hit the ground. Then you use that time by substituting it into the velocity function to get the actual value of the speed, which is a positive. So the answer will be 40 meters per second. Do you have any question there? So we substitute h equal to 0 because at ground level the height is 0. Then we solve the quadratic equation. We've got two values of t. We reject the negative one because time is never negative. We take the positive, then we substitute the positive value of t into the velocity function. Then we will be able to get our velocity, which is a negative, but speed is never negative. Therefore, the answer will be 40 meters per second. Then number 8, was the stone speeding up or slowing down after exactly 2 seconds? Right? So let's see. Now, after 2 seconds, so take 2 seconds, right? V is 10 meters per second, acceleration is minus 10 meters per second. Now, you might be asking, where am I getting these answers from? Right? The first derivative, if you put t equal to 2 here, you will get 30 minus 20, which is equal to 10 meters per second. Right? Then if you find the derivative of the first derivative, you get acceleration. We already got these values previously. So you get minus 10 meters per second squared. Now, since the velocity is positive but the acceleration is negative, that's a sign that the object is slowing down. The speed or the velocity is positive, but the acceleration is negative. Therefore, the object is slowing down. Right? Then we do the same. Right? So V is h prime. After 5 seconds, we substitute t equal to 5 into the velocity function. We get 30 minus 50 gives us minus 20 meters per second. Then the acceleration is 2 minus 10 meters per second. Now, since we have the same sign here and there, they are both negative. That's a sign that the object is speeding up. As long as the velocity and the acceleration have the same sign, then the object will be speeding up. But if their signs are different, then the object will be slowing down. Alright?